Okay, now we have quantization, but we need to, make sure that the quantization is not garbage. Like the quality, I mean, like the accuracy, right? And this is why we also have evaluation, evals for quantization. So we have something called perplexity, KL divergence, KDL. I wouldn't name it completely because I'd completely be mistaken for sure. MMLU, and I wanted to ask Colin to talk about perplexity and also like why KDL, what is KDL and why is it better in most of the cases. I think you explained that to me online in Twitter once, but I would like the audience to listen to you.
Yeah, so perplexity is this idea that given a, a series of text, how surprised is the model by the next word? And so, assuming a very high quality corpus of text, low perplexity is what you're most hoping for. You want it to be very low. You want the model to not be surprised by what the next word is, because ideally it should be quite smart and able to predict within reasonable human text. What KLD or KL divergence comes in and does is it kind of tries to compare two models and the difference in their level of surprise. So if you quantize, especially if you quantize in a way that targets a specific data set, and then you were to then measure perplexity against that data set, that quantized model is likely to not be at all surprised by the text that's in there because it's been specifically optimized to more likely guess that text. And so that's why, like, if you just look at the perplexity number, it's kind of a good smoke test. If a very high number shows up, you know something is probably wrong. Something's going off here. Like 10 or higher is like, whoa, what's going on? But if you get 2 to 5, you're like, okay, this is probably competent. Everything's probably okay. Especially when it comes to quantization, like those numbers can really balloon rapidly. But if you have an original model with a specific perplexity and a quantized version of that model with another specific perplexity, comparing them only gives like part of the story. It says like, okay, yeah, it's still like you didn't destroy it. It's still pretty good at guessing this text, all things considered. What KLD comes in and does is it actually does a more specific measurement of the tokens that are being predicted and how likely it is at any step, like what's the 99th percentile of tokens that it guesses wrong. How often is the top token that it predicts the exact same token? Things like that. Like how likely is it to be very different in its prediction? So those kinds of measurements kind of paint a more full picture. Theoretically speaking, assuming that data is not being contaminated in any way, they are extremely correlated, perplexity and KLD. And so like in a vacuum, one should mostly give you the answer to the other. But when you really want to get into the specifics and you really want to push for accurate measurement, getting that KLD, especially on a relatively random set of data that the models for sure didn't see during the quantization process, is really important for painting that more full picture and letting you know exactly how similar the models are after quantization.
So basically, perplexity, you compare the result from like a full precision model based on an input output to the quantized one, right? And then perplexity is like, hey, it's like talking about ice cream, and then it's talking about a trunk of a car, no relation.
Yeah.
So that's like high perplexity because hey, you're perplexed
exactly.
when you hear something like a story that like a punchline that has nothing to do with the beginning of the story, something like that, right? And KDL is more comparing what, like the probability of those perplexity or like those bad precision, like bad like inaccuracy probability.
Yeah, and importantly, like it's entirely possible that both the original model and the quantized model are really bad at predicting this text for some reason. But the important thing is, are they similarly bad? Like, are they behaving in the same way, or are they similarly good? Are they usually trying to predict the same token, but like it doesn't matter if it's wrong? Are they still doing the same thing? And that's where it's important.
Interesting. So, like in GitHub, people can just maybe check QLD now, maybe a bit more than Perplexity, is like as much or even more from now on.
Unfortunately, it is much more
reliable.
expensive to do because you have to run it against the original model and it's like save that and then run it against the quantized model and save that. And so it is a more time-consuming process and a more compute-intensive process than just measuring the perplexity, which again is usually enough for most people because it just gives you that little quick smoke test of okay, is it completely off the rails, or are we looking at like did everything kind of go okay? And that's usually all people really care about, except for when you get into the real nitty gritty.
Yeah, that's why Q4K is like everybody's best model in terms of perplexity, because it's a win-win for everything. But like are you seeing a pattern of quantizer using QLD as a sort of a benchmark of quality of their quantized model, or it's up to who quantizes?
It's kind of up to who. I know that like Unsloth has released a few here and there, mostly when the original DeepSeek V3 came out, because there was some deficiencies in the way that Llama CPP was quantizing particularly large MOE models. We hadn't seen them in a while, so no one was really doing anything to try to optimize for them. And so there was a couple of key areas that needed some updating. And with those updates, it did massively improve the perplexity and the KLD. But overall, no, most people like don't bother. It's a bit of a excessive metric. I like it. It's a lot of useful information. And if you really like are trying to especially optimize something for some reason, like, or you're trying to find a new quantization format, like that makes more sense in terms of what layer get quantized to what level. Like it's super helpful for that. But overall, it's not like you don't really need it. You'll usually do pretty okay with just perplexity. And if you really wanted to, you could run some benchmarks. But yeah, KLD is definitely what I would call the gold standard of finding out the quality of the quantization in relation to the original model. It doesn't tell you that it's a good model. It just tells you that it's similar to the original.
How similar?
Yeah, exactly.
Nice. Gotcha. Glad. Nice to know that you're a perfectionist. So you're keeping up with the KLDs and stuff. That's a good habit to have. Eldar, on the VLM side, like LM compressor, once you're done, like you applied your recipe, how do do your evals for your quantized model?
It's very similar story, actually. So maybe just to mention one thing regarding the KL divergence. This is actually what is exactly used in the knowledge distillation. So what we talked before, when you have larger teacher and smaller like a student model, KL divergence is the metric you actually want to optimize for. Because for each token at the output, it tells you how similar is the probability distribution that one model produced versus the other. And in the case of quantization now, just the teacher is unquantized model and the student is a smaller quantized one. Yeah, and it's like a perfect metric kind of just to get like this, like a similarity score against the larger or unquantized model. However, one main kind of problem, at least on the kind of like when you're trying to present the results, it's not that clear on what does it mean when you drop 0.5 in KL divergence or perplexity. That's why, at least internally, we do use perplexity and KL divergence for our own investigation. But kind of when we want to release a model, then we kind of switch over a bit to like these more standardized tests like MMLU, GSM8K, human eval, arena hard, and so on. So it's something where you actually have accuracy. So you can tell to a user, okay, if you take unquantized model, the accuracy is 85. If you take the quantized one, accuracy is 84. So it's kind of what we got used to, like scale 0 to 100, and I can exactly see how bad my model is relative to the
right. So like you compared it like it was a completely different model in a benchmark. So because back in the days, like I was using GGUFs and I was comparing perplexity, and I was like, okay, this value is fine, and I will try it again and then like see the vibe, how it looks like, how it it replies to me. Are the output good, or is it like completely hallucinated from like the first prompt? Right. And then I would see the MMLU. I would see how do you call it? GPQA. Is that it?
Yeah,
One of
yeah,
the,
yeah.
yes, GPQA, or like the math, and like now we have the SWE benchmarks and stuff. So internally, you would go for Perplexity and KLD, but like with the customers, they have only one language, which is like the LM Arena benchmarks, right? But like
Yeah,
for
yeah.
you as a technician, as like a scientist, which one would you go for?
So when you're quantizing a model, usually what you're doing, you have to play a bit with hyperparameters, right? Like the size of the calibration data, some like different dampening factors, blah, blah, blah. And during this process, you want something that you can compute very quickly because you're going to run, like this is like iterative process, you're optimizing for something. So you're going to produce a lot of quantized models. So you want something that you can compute very quickly just to judge the quality of one versus the other. And in this case, like Perplexity, for example, is like a very good, or KL divergence is very good. You can run it very quickly. You get the feedback immediately, and you see, okay, this is a better model on this one. I'm going to ship this one. And the once you're ready in this kind of exploration phase, then you start running these like a little bit more expensive benchmarks, like MMLU, Arena Hard, and so on. And that's basically what you all like present to the outside world. Right, this is because that's what people usually care about. If I take a quantized model, what's the drop on the math 500 that I'm going to see?
Yeah, so
it's
that's
like
the street.
1% or 20%. Yeah,
You showing your watch on the street and say like, this is like a pretty much like a real Rolex, but it's cheaper.
yeah.
Okay.
Yeah. Because it's very
I
hard
got
to like at least for like non-technical people, it's very hard to like quantify whether a drop in perplexity of if perplexity dropped from 7 to 5, what does that mean? Is the model like completely destroyed, or it's still like good enough?
You still gotta try it.
Yeah, that's right. You have to try it. But here, if you say, accuracy dropped from 85 to 83, it's something I can live with, right?
Yeah. Candid question though, like, do you guys believe in those benchmarks? Because some models are really trained based on these benchmarks. So,
not really.
Right?
Not really.
It's like, is it like all hype shit?
There is a
marketing
There is a ton of papers which actually show that a lot of these models are kind of contaminated with the benchmarks. Like, I'm not sure if you have. Yeah, I mean, like.
Do you think Llama 4 has been a bit? Because a lot of people accused them at some point.
I don't know. I mean, so there's this process of they're probably not doing that intentionally. That's like the first thing to clear up.
That's what I heard everywhere.
But the problem is that the pre-trained data is like 15 trillions of tokens, right? So it's very hard kind of to say reliably that there are no examples of MMLU, for example, samples in those 15 trillion tokens. And there's specifically, I think, paper from maybe a year or two ago, which showed that if you take MMLU benchmark, which is like a multiple choice. So you have a question, you have 4 answers, A, B, C, D. And then you evaluate the model, you get 1 score. And then if you just flip the order, of the answers, instead of doing A, B, C, D, you just flip maybe A and C. Like all of the state-of-the-art models drop by 5 to 20 points in accuracy. If you just flip, so everything is the same question, the same answer, you just flip them, and the accuracy drop, which is probably if you're taking 15 trillion tokens from internet, there is a high chance that you will probably pick up unintentionally some form of the evil benchmarks in there, and the model is gonna say it.
Yeah, so to be taken by a big grain of salt.
Yeah, yeah. That's why we usually prefer at least when working with customers, like these general benchmarks are a good kind of first step. Just to get the gist of whether the model is producing garbage or not. But then usually they have some specific applications where they're using LLMs. Whether you're generating some specific code for some specific language, whether you're doing summarizing the text, blah, blah, and then you actually evaluate in that setup, because that's what matters in the end, right? If you're deploying a model for summarization of some specific set of documents, you actually want to evaluate it there. And that's what we use as the final kind of score and metric on how good quantization is relative to the baseline.
Interesting. And Kimi K2, by the way, they're saying that it's it's made for agentic AI. It's really trained for agentic use. Do you actually believe in this kind of premises and this kind of claim because cold tooling was there a long time ago? I mean, Llama was had function calling were there. And a lot of what we're seeing today in LangGraph is using the existing models, right? So it's not like you need to create a new one that is like, you can't say like, oh, this is specific to agents. While all the agents that are running until now, we're using other models. Like, how credible would be this kind of claims? Obviously, it's like it's been a couple of days since it was released, but did you believe there's like a agentic only model?
I mean, not necessarily agentic only, but agentic focus does
Friendly.
not surprise me. Yeah.
Mm-hmm.
Like there is definitely optimizations to be made with, function calling, things like that, like dealing with the results of it, treating them as ground truths, where, models of old, yeah, they could run functions. They could figure it out. They were smart enough to understand formatting of JSON, things like that. But adding it to the training data and focusing specifically on it is obviously quite important and helpful for stability of using these tools and becoming an agentic platform.
Interesting. Eldar, any thoughts?
I mean, no, I 100% agree with what Colin said. Like, basically, it's just that they are leaning a little bit more towards like being able to know and to leverage the tools and function calls when they need them. Because previously, for example, Llama and all these models, it's just like a bunch of text. You just train it on that, and it's like doing next token prediction. Whatever is the most likely like next token, it's going to predict it. Whereas here, you actually, the model knows that it can use these tools when they're needed. Yeah.
So would you say wait and see then, until people get some feedback out of a model like this?
Yeah, I'm sure it'll be good, and I'm sure it'll be good at some things. I don't know if it'll be like necessarily state of the art, like the level that people are gonna have to quantize it to run it locally. It's only gonna be for fun, like just to say like, hey, I ran a 1 trillion parameter model, and that is cool. That is very cool. Yeah. Don't get me wrong, but like DeepSeek, even the original one, it's difficult to run it quickly as well. Like the sheer size that it requires makes the infrastructure quite difficult to maintain. So it has been revolutionary for like the open source world. They released and like it's nice that they released so much interesting stuff with it, like all their learnings. They've got their MLA cache, which was really impressive. A lot of stuff that they did was super cool. And kudos to them for releasing it all openly. But in terms of running it local and being like a local model, it is difficult to say that it is going to change up a lot of stuff, at least for people. Most of the workflows that I know of.
You bet. Well, they can always run it on Grok.
Exactly.
Or some inference service, for sure.